In the winter of 1942, as Allied forces struggled against Nazi Germany across multiple theaters, the United States faced a critical challenge on the battlefield. The American M4 Sherman tank, backbone of U.S. armored divisions, was being consistently outperformed by German Panzer IV and Tiger tanks across North Africa. This disparity wasn't merely a technical curiosity. It was costing American lives daily and jeopardizing crucial battlefield objectives. Archival footage from Operation Torch shows Sherman tanks moving sluggishly across desert terrain, with Panzers visibly faster in the distance, outmaneuvering their American counterparts with deadly efficiency. Military cameramen captured the frustration of American tank commanders as they struggled to bring their Shermans into favorable firing positions, only to find that their German opponents had already relocated to more advantageous ground. The Sherman's inferiority wasn't just a matter of armor thickness or firepower, though those deficiencies would later prove costly as well. One of its most significant disadvantages was speed and maneuverability. The Sherman's original transmission system, designed for reliability rather than performance, limited its top speed to approximately 24 miles per hour on ideal terrain, significantly slower than the German Panzers that could reach up to 38 miles per hour. This speed differential meant that American tanks were frequently unable to reposition quickly enough during battle, leaving them vulnerable to flanking maneuvers. This mobility gap became painfully evident during the Battle of Kasserine Pass in February 1943, when inexperienced American forces faced Erwin Rommel's veteran Afrika Korps. After-action reports described how German Panzer IV tanks repeatedly outflanked American positions, exploiting their superior speed to attack from unexpected directions. The result was a significant American defeat, with 183 tanks lost and over 6,000 casualties. Military historians note that the Sherman was essentially a compromise tank, reflecting America's need to balance performance with mass production capabilities. It was designed to be manufactured quickly, transported easily across oceans, and maintain reasonable reliability in the field. These engineering compromises became liabilities in combat, particularly as American forces prepared to face the main strength of the German army in the planned invasion of Europe. American tank crews often referred to their Shermans as death traps or Ronsons, after the lighter company whose slogan was "Lights first time, every time," a grim reference to how quickly they could catch fire when hit. Letters home from frontline soldiers revealed their growing concern about facing superior German armor with inadequate equipment. At the Detroit Arsenal tank plant, production lines were churning out hundreds of Sherman tanks monthly. The arsenal employed over 5,000 workers, many of them women who had entered industrial work for the first time as part of the war mobilization. 3 shifts operated around the clock, with production continuing even on holidays and weekends. But reports from the front lines were causing serious concern among military leadership. General George S. Patton, after observing tank battles in North Africa, sent a blistering memo to the War Department. "Our tanks are mechanically reliable, but tactically inadequate. The ability to reach the battlefield means nothing if we cannot maneuver effectively once we are there." It was here, amid the ceaseless din of industrial production at the Detroit Arsenal, that Frank Moretti worked as a senior mechanical engineer specializing in drivetrain systems. Born to Italian immigrants in 1904, Moretti had grown up fixing farm equipment in rural Pennsylvania before earning a scholarship to study engineering at Cornell University. By 1942, he had established himself as one of Detroit's most innovative automotive engineers, with several patents to his name for transmission designs. A surviving photograph shows Moretti in his work clothes. A stocky man with dark hair and intense eyes, hands permanently stained with engine grease, his face bearing the focused expression of someone who solved problems for a living. Former colleagues described him as obsessively detail-oriented, often spending hours examining a single component to understand its function within the larger system. When the war began, Moretti immediately volunteered his expertise to the war effort, taking a significant pay cut to move from the automotive industry to military production. As a first-generation American with relatives still living in Italy, now an enemy nation, Moretti faced occasional suspicion despite his impeccable credentials. His intimate knowledge of transmissions and drivetrains ultimately made him an invaluable asset to the tank program, and by mid-1942 he was leading a team of engineers focused on drivetrain improvements for the Sherman. Colleagues recall that Moretti was rarely seen outside the factory, often working 16-hour days and sleeping on a cot in his office. "We knew our boys were dying because of design problems we hadn't solved yet," one Arsenal engineer later wrote. That knowledge haunted all of us, but Frank took it the hardest. He felt personally responsible for every tank that left the factory. In January 1943, Colonel William Davidson of Army Ordnance summoned Moretti to his office. Military records indicate that Davidson had been tasked with finding solutions to the Sherman's mobility issues after several scathing field reports from North Africa. The meeting would change the course of Moretti's life, and potentially the war itself. The colonel's office was Spartan, with maps of Europe and North Africa covering one wall and technical schematics of the Sherman tank on another. According to witnesses, Davidson told Moretti directly, "I've been authorized to form a special engineering task force. We need to solve the Sherman's mobility issues before the European invasion. The Germans have had years to fortify the continent. When our boys land, they'll need tanks that can outmaneuver the enemy." Moretti's response was equally direct. "Sir, I've been studying the problem. The transmission is the bottleneck. It's not just about raw speed, it's acceleration, turning radius, climbing ability. The whole drivetrain needs to be reconsidered." Colonel Davidson gave Moretti an unprecedented mandate: assemble a team, requisition whatever resources were needed, and solve the Sherman's mobility problems within 6 months. The timeline seemed impossible, but the stakes couldn't have been higher. The Allied invasion of Europe was already in the planning stages, and any major tank modifications would need to be implemented well before the landing date. Documents show that Moretti immediately recruited 7 engineers for his special project, codenamed Operation Jackrabbit. The team was given a secured workshop in the east wing of the facility, with round-the-clock military guards stationed at the doors. Inside, they set up a complete Sherman tank for testing, along with machining equipment and drafting tables. Moretti's first action was to completely disassemble the Sherman's transmission system, cataloging each component and measuring performance values. The team worked around the clock, conducting stress tests, measuring heat generation during operation, and calculating efficiency losses throughout the power transfer system. The fundamental problem, as Moretti explained in his preliminary report, was that the Sherman's transmission had been designed with manufacturing efficiency as the primary goal. It used a 5-speed synchromesh transmission similar to those found in heavy trucks, modified for the tank's weight and power requirements. While reliable and easy to produce, it suffered from efficiency losses that reduced both speed and fuel economy. Moretti's team began exploring multiple solutions. They experimented with different gear ratios, alternative lubricants, and cooling systems. They tested various metals for gear construction, seeking materials that could withstand higher stress while maintaining durability. Progress was slow. After 6 weeks, they had achieved only marginal improvements in performance, perhaps a 5% increase in top speed, but nothing revolutionary. The pressure from Washington increased. General Patton himself, after experiencing the mobility limitations of Sherman tanks in Tunisia, sent a telegram demanding, "Give me tanks that can chase, not just be chased." The breakthrough they needed would come from an unexpected source: the battlefield itself. While Moretti assembled his team in Detroit, Thousands of miles away in North Africa, American forces were experiencing firsthand the tactical advantages of German engineering. Military footage from February 1943 shows dust-covered Sherman tanks struggling across rocky terrain, while captured film reveals panzer units executing rapid flanking maneuvers, their superior mobility evident even in grainy black-and-white images. The North African campaign had turned into a brutal learning experience for American armored units. Tank commanders were developing improvised tactics to compensate for their vehicles' limitations, but the fundamental performance gap remained. Combat reports described numerous instances where American tank units were simply outmaneuvered by their German counterparts, unable to bring their guns to bear effectively or retreat when necessary. Lieutenant Colonel Creighton Abrams, then commanding a tank battalion in Tunisia and later to become Chief of Staff of the U.S. Army, wrote in a field report, "Our Sherman tanks are consistently outperformed in mobility by German armor. This is not a matter of driver training or tactical doctrine. It is a fundamental limitation of our equipment. When German tanks decide to disengage, we cannot pursue effectively. When they decide to flank our positions, we cannot reposition quickly enough to counter them." In late February 1943, a pivotal moment occurred during the Allied advance following the Battle of Kasserine Pass. An American reconnaissance unit from the 1st Armored Division discovered an abandoned German repair depot outside Tunis. The facility had apparently been evacuated in haste, with tools left on workbenches and partially disassembled vehicles still on maintenance lifts. Among the spoils of war was a partially disassembled Panzer IV tank. Captain Thomas Shelby, an engineering officer attached to the 1st Armored Division with a pre-war background in automotive design, immediately recognized the significance of the find. Within the Panzer's disassembled components lay the Maybach transmission, the heart of German tank mobility. Shelby's field report, marked Urgent Technical Intelligence, stated, "German transmission design represents significant advancement over current American systems. Recommend immediate technical analysis." The report included detailed preliminary observations, noting that the German transmission utilized a fundamentally different approach to gear arrangement and power distribution. The German transmission employs a sophisticated planetary gear system that appears to offer significant advantages in power transfer efficiency, Shelby wrote. The gear ratios are optimized for rapid acceleration and deceleration, clearly designed with combat maneuverability as the primary consideration. Additionally, the cooling system is integrated directly into the transmission housing, allowing for more effective heat dissipation during sustained operation. Recognizing the potential value of this intelligence, Shelby ordered the entire transmission system crated and shipped back to the United States with highest priority. Military transport records show the crate was assigned special handling designations, with orders signed by General Omar Bradley himself, authorizing the use of scarce air transport resources. 3 weeks after its discovery in Tunisia, the crated German transmission arrived at the Detroit Arsenal. Frank Moretti was called to examine it immediately. Security around the delivery was intense, with armed MPs escorting the crate to a specially secured room adjacent to Moretti's workshop. Eyewitness accounts from that day describe Moretti's reaction when they uncrated the transmission. One of his assistants, David Cohen, later recalled, "When they removed the crate lid and Frank saw what was inside, his expression changed completely. He became absolutely focused, like nothing else in the world existed. He circled it like a hawk, touching nothing at first, just observing. Then he started taking measurements, making sketches. He worked through the night, meticulously documenting every aspect of the German design." What Moretti saw in the German design was revolutionary, not because of exotic materials or manufacturing techniques, but because of fundamental design philosophy. The Maybach transmission utilized an ingenious planetary gear system that allowed for smoother power delivery, more efficient gear changes, and crucially, better power-to-weight ratio. Engineering experts note that the German transmission wasn't using any materials the Americans didn't have access to. It was simply designed with different priorities: performance over ease of manufacturing, efficiency over simplicity. The Germans had approached the problem from first principles, designing a transmission specifically for the demands of armored warfare, while the Americans had adapted existing commercial designs to military use. For 2 weeks, Moretti and his team meticulously reverse-engineered the Maybach transmission, learning everything they could from their enemy's design. They disassembled it completely, measuring each component with precision instruments, creating detailed technical drawings, and conducting metallurgical analysis of key components. Surviving technical drawings from this period show detailed cross-sections of the German gearbox alongside the American version, with Moretti's handwritten notes comparing efficiency rates, heat generation, and power transfer capabilities. His analysis identified several key advantages in the German design. 1. The planetary gear arrangement allowed for more efficient power transfer, reducing energy loss during gear changes. 2. The gear ratios were specifically optimized for the acceleration and deceleration profiles needed in combat. 3. The integrated cooling system maintained optimal operating temperatures even during extended high-performance operation. 4. The bearing surfaces were designed to handle lateral loads more effectively, improving performance during turning maneuvers. 5. The control mechanisms allowed for faster gear changes, reducing the time needed to shift from forward to reverse, a critical factor in evasive maneuvers. But they faced a dilemma. There wasn't time to completely redesign the Sherman's powertrain. The invasion of Europe was already being planned for the following year. Any solution had to work with existing tanks and production lines, and it had to be implementable within months, not years. This is where Moretti's genius really showed. Instead of trying to copy the German design wholesale, he looked for the critical elements that could be adapted to the existing Sherman transmission. Military equipment experts describe it as surgical engineering, identifying precisely which components could be modified using existing manufacturing capabilities while delivering the maximum performance improvement. In a crucial meeting with Colonel Davidson in April 1943, Moretti presented his approach. We can't replace the entire transmission system without disrupting production, but we can integrate key elements of the German design into our existing system. I've identified 3 critical modifications that can be implemented with minimal disruption to the production line. The solution Moretti devised became known as the hybrid transmission modification, or more colloquially among the engineers, the stolen gearbox fix. His approach was not to replicate the entire German transmission, but to incorporate its most efficient elements, specifically the planetary gear arrangement and the integrated cooling system, into the existing Sherman design. A key insight came when Moretti realized that the Sherman's transmission housing could be retained with minimal modifications while completely redesigning the internal gear arrangement. This meant that the new transmission could be installed in existing tanks with relatively minor modifications to the hull, solving the critical problem of battlefield upgradability. Moretti's team worked around the clock to develop the hybrid design. They created multiple prototypes, each refining the concept further. Testing was rigorous, with each iteration subjected to simulated battle conditions on the arsenal's test track. By late April 1943, after numerous refinements and 3 complete redesigns, the team had created a working prototype that achieved their performance goals while maintaining the required durability. The modified transmission delivered an 18% increase in top speed, pushing the Sherman from 24 to nearly 30 miles per hour on flat terrain. More importantly, acceleration improved by 24%, allowing the tank to reach its top speed much more quickly and execute rapid directional changes more effectively. The first complete prototype was assembled in May 1943. Testing on the Arsenal's enclosed track showed promising results, not only the improvements in speed and acceleration, but also a 15% improvement in fuel efficiency, extending the Sherman's operational range significantly. But laboratory tests were one thing. Battlefield conditions were another entirely. Colonel Davidson authorized a field test using a modified tank in comparison trials against a standard Sherman. The tests were conducted at the Army's proving grounds at Aberdeen, Maryland, where both tanks were put through a series of demanding exercises designed to simulate combat conditions. The results were definitive. In every mobility category, acceleration, hill climbing, turning radius and top speed, the modified tank outperformed the standard model by substantial margins. Most significantly, its speed profile now matched or exceeded that of the Panzer IV, the workhorse of German armored divisions. The engineering team had achieved what had seemed impossible just months earlier. They had closed the mobility gap with the Germans without requiring a complete redesign of the Sherman. A report filed by the test officer stated, "Modified transmission delivers game-changing mobility improvements. Recommend immediate implementation." Within days, Moretti was presenting his solution to the highest levels of Army ordnance. The order came directly from General Leslie McNair, commander of Army Ground Forces. Begin production immediately. Priority status authorized. But significant challenges remained. Converting the theoretical success of a prototype into mass production would require the retooling of production lines, training of assembly workers, and coordination across multiple manufacturing facilities. And there was precious little time. The Allied invasion of Europe, Operation Overlord, was scheduled for the following spring. Thousands of tanks would need the new transmission by then. The third phase of Moretti's wartime achievement began in May 1943, when his engineering solution transitioned from prototype to mass production. This presented challenges that were in many ways more daunting than the technical obstacles he had already overcome. The Arsenal's manufacturing floor was already operating at maximum capacity, producing standard Sherman tanks 24 hours a day, 7 days a week. Any disruption to this production schedule could impact the flow of vital equipment to frontline units. Archive footage from the summer of 1943 shows the Detroit Arsenal's massive production floor, with assembly lines stretching across the facility. Workers, many of them women who had joined the industrial workforce during the war, moved with practiced efficiency between assembly stations. Signs hanging from the ceiling proclaimed, "Production equals victory," and "Every tank saves lives." To implement Moretti's transmission modifications without halting production required meticulous planning and innovative manufacturing approaches. The fundamental challenge was to integrate the new components into the existing production flow without creating bottlenecks or requiring extensive retraining of the workforce. Moretti's solution was to establish a parallel production line specifically for the new transmission components. Factory floor plans from June 1943 show how he reorganized the eastern section of the facility, creating a separate production area devoted exclusively to the modified transmission. This approach allowed the new components to be manufactured simultaneously with the standard parts, minimizing disruption to the main assembly line. The first challenge was tooling. The modified transmission required precision-machined gears with different tooth profiles than the standard parts. New dies, cutting tools, and quality control gauges had to be created from scratch. Moretti recruited specialists from automotive plants across Michigan, bringing together machinists, tool and die makers, and quality control experts. Within 3 weeks, they had created the specialized tools needed for production. The gear-cutting operations were particularly challenging. The planetary gear system required more precise tolerances than the standard transmission, with complex tooth profiles that had to mesh perfectly to achieve the desired performance. Moretti worked with metallurgists to develop heat treatment processes that would ensure the gears maintained their strength and durability under the extreme stresses of combat operations. Training was the next hurdle. The assembly of the new transmission required greater precision than the standard model, with tighter tolerances and more complex assembly sequences. Moretti instituted a specialized training program for selected workers, running afternoon sessions after their regular shifts. Photographs from these training sessions show Moretti himself demonstrating assembly techniques, his hands guiding workers through the intricate process of aligning the new planetary gear systems. Ruth Wilson, one of the Rosie the Riveters who worked on the transmission line, later recalled, "Mr. Moretti wasn't like some of the other engineers who'd just hand you a blueprint and expect you to figure it out. He'd show you exactly how to do it, and he'd explain why each step mattered. He treated us like we were part of the team, not just pairs of hands." One of the most significant challenges was supply chain management. The new transmission required slightly different raw materials, specific grades of steel for the gears, synthetic rubber compounds for the seals, and specialized lubricants. In the midst of wartime material rationing, securing these additional resources required navigating bureaucratic obstacles and finding creative solutions. Procurement records show how Moretti worked with the War Production Board to reclassify his project to the highest priority level, ensuring the necessary materials were diverted to Detroit. When certain specialized steel alloys proved difficult to obtain in sufficient quantities, he collaborated with metallurgists to develop alternative formulations that could be produced using more readily available materials. By July 1943, the first production run of modified transmissions was completed, 100 units, each carefully inspected by Moretti's team. The next phase would prove even more challenging, upgrading tanks already in service. Military logistics experts developed a two-pronged approach. New tanks would receive the modified transmission during manufacturing, while tanks already in service would be upgraded at field maintenance depots in England, where American forces were building up for the invasion of Europe. To facilitate this field upgrading, Moretti created detailed technical manuals and even a training film demonstrating the retrofit procedure. The 16mm instructional film, preserved in military archives, shows step-by-step instructions for removing the old transmission and installing the new one, with Moretti himself narrating the process. The film emphasized the critical alignment procedures and special tools required, ensuring that field mechanics could complete the upgrade correctly, even without direct supervision. The retrofit could be completed by experienced mechanics in approximately 8 hours, meaning a tank could be upgraded overnight and returned to its unit the following day. This rapid turnaround was crucial, as units couldn't afford to have their tanks out of service for extended periods. The upgrade kits, containing all necessary components and specialized tools, were packaged in sturdy wooden crates for shipment to overseas maintenance facilities. By September 1943, production was reaching 500 modified transmissions per month. Quality control was paramount, with each unit undergoing rigorous testing before installation. Testing photographs show the transmissions being subjected to stress tests on specialized dynamometers, simulating battlefield conditions, including extreme temperatures, rough terrain, and sustained high-speed operation. A critical moment came in October 1943, when General George Patton visited the Detroit Arsenal during a brief return to the United States. Having experienced the limitations of Sherman tanks firsthand in North Africa, Patton was keenly interested in Moretti's modifications. Photographs show Patton and Moretti standing beside a cutaway display of the new transmission, with Moretti explaining the technical improvements. According to witnesses, Patton asked pointed questions about performance specifications, particularly acceleration and cross-country speed. He was especially interested in the transmission's performance on rough terrain, understanding that European battlefields would present different challenges than the North African desert. After the demonstration, Patton reportedly told Colonel Davidson, "This is exactly what we need for France. The terrain there will demand mobility above all else. If these modifications work as advertised, they'll save thousands of American lives." Patton's endorsement accelerated the implementation timeline. By December 1943, all new Sherman tanks were being produced with Moretti's modified transmission, and depot facilities in England were upgrading existing tanks at a rate of 20 per day. Training programs ensured that maintenance crews understood the new system, with particular emphasis on the improved cooling system that was critical to the transmission's performance. The logistical challenge of the upgrade program was enormous. Each modified transmission required approximately 200 pounds of specialized steel, rubber, and other materials. Production and shipping records show that between July 1943 and May 1944, over 6,000 modified transmissions were manufactured and shipped to various theaters of operation, with the majority going to England in preparation for the invasion of Europe. As 1944 began, the impact of Moretti's work was becoming evident in the performance statistics of American armored units training in England. Exercise reports show that units equipped with modified Shermans consistently outperformed those using standard tanks in maneuver exercises, with improved fuel efficiency allowing longer operational ranges without resupply. A significant concern had been reliability. Would the modified transmission hold up under combat conditions? Initial testing had been promising, but the true test would come in combat. To address these concerns, Moretti implemented a comprehensive feedback system, with maintenance units required to report any transmission failures or issues. The data would be analyzed in Detroit, allowing for continuous improvement of the design. By April 1944, with the invasion of Europe just weeks away, approximately 60% of Sherman tanks in England had been upgraded with the new transmission. Priority was given to units scheduled for the first wave of the invasion, ensuring that the tanks that would spearhead the Allied return to France would have the mobility advantages Moretti had worked so hard to provide. As the final preparations for D-Day were underway, Moretti received a brief telegram from General Omar Bradley. "Transmission modification program exceeding expectations. Your contribution will save lives and help win this war." For Moretti, who had worked nearly around the clock for a year and a half, this simple acknowledgement from a frontline commander meant more than any formal recognition. The true test of Moretti's innovation was about to begin on the beaches and bocage of Normandy. At dawn on June 6, 1944, the greatest amphibious invasion in military history began on the beaches of Normandy. As infantry struggled to establish beachheads, specially designed Sherman DD, duplex drive tanks, amphibious variants with canvas flotation screens, swam ashore to provide crucial fire support. While many of these specialized tanks were lost to rough seas and enemy fire, those that made it to the beach demonstrated the first real-world application of Moretti's modified transmission. Improved power delivery allowed them to move more effectively through the soft sand and scale the beach obstacles, providing vital covering fire for advancing troops. Combat footage from D-Day shows several Sherman tanks rapidly traversing Omaha Beach, their improved mobility allowing them to reach protective seawalls and then provide covering fire for pinned-down infantry. Veterans of that day would later recall how the tank's ability to maneuver quickly across the exposed beach was crucial to breaking the deadly stalemate that had developed during the initial landing phases. Staff Sergeant Michael Collins, a tank commander with the 743rd Tank Battalion at Omaha Beach, wrote in his after-action report, "Our ability to accelerate quickly after hitting the beach was essential to our survival. German anti-tank guns had pre-ranged the waterline, and any hesitation meant certain destruction. The new transmission gave us the burst of speed we needed to clear the killing zone." But it was in the days following D-Day that the full impact of the stolen gearbox fix became apparent. The terrain inland from the Normandy beaches presented a nightmare scenario for armored warfare. The bocage, ancient farmland divided by high earthen berms topped with dense hedgerows. These natural obstacles created a labyrinth of enclosed fields, each one a potential ambush point for defending German forces. Aerial photographs from June 1944 reveal the challenging nature of the bocage landscape, a patchwork of small fields separated by hedgerows up to 15 feet tall, with roots going back centuries. German defenders had transformed this terrain into a defensive stronghold, positioning anti-tank guns and infantry with Panzerfausts, handheld anti-tank weapons, to ambush Allied armor as it attempted to navigate through the narrow lanes and field openings. In this environment, tank mobility was paramount. Standard Shermans had struggled to penetrate the hedgerows, often exposing their vulnerable undersides as they attempted to climb over the berms. The modified transmission, with its improved torque delivery and acceleration, allowed tanks to approach the obstacles with greater momentum and power through them more effectively. Tank crews developed techniques to breach the hedgerows that specifically leveraged their improved mobility, approaching at angles that maximized traction and minimized exposure. Lieutenant Colonel Crichton Abrams, commanding the 37th Tank Battalion, reported after an engagement near Carentan, "Modified Sherman tanks demonstrated superior mobility in bocage terrain. Ability to accelerate quickly after breaching hedgerows provided crucial tactical advantage against German anti-tank positions. In 3 separate engagements, our tanks were able to close distance with enemy positions before they could adjust their aim, neutralizing their range advantage. The improved maneuverability proved especially valuable during the close-quarters fighting in the Norman countryside. Tank commanders reported being able to execute more aggressive flanking maneuvers, using the terrain features to mask their movements and then rapidly repositioning to attack from unexpected directions. The German defenders, accustomed to the slower response times of the original Sherman transmission, frequently found themselves outmaneuvered by the more agile modified tanks. Perhaps the most dramatic demonstration of the modified transmission's impact came during Operation Cobra in late July 1944, when American forces finally broke out of the Normandy beachhead and began their drive across France. As German defenses collapsed, the campaign became a war of movement, exactly the scenario Moretti had envisioned when designing his transmission upgrade. The 2nd Armored Division, nicknamed Hell on Wheels, covered 75 miles in a single day during the pursuit phase, a feat that would have been impossible with the original transmission's limitations. Their after-action report stated, "Improved acceleration and sustained speed capabilities were crucial to maintaining pressure on retreating enemy forces. In multiple instances, our tanks were able to overtake and engage German rearguards before they could establish defensive positions. German prisoners captured during this phase frequently expressed surprise at the speed with which American tanks had overtaken their retreating forces." Interrogation reports quote one Panzer officer as saying, "We were told American tanks were slow and clumsy, but they seemed to be everywhere at once, appearing on our flanks before our defensive positions were properly established." Luftwaffe reconnaissance reports from August 1944, captured after the war, noted with alarm American tank formations demonstrating unprecedented mobility rates, advancing 42 to 60 km per day across open terrain. Pursuit speed exceeds our ability to establish defensive positions. This German assessment perhaps best illustrates how Moretti's engineering solution had translated into tactical advantage. As Patton's Third Army raced across France in August 1944, the mobility advantage became even more pronounced. The German strategy increasingly relied on mobile defense and counterattacks, attempting to use their remaining panzer formations to blunt American advances. In these fluid, fast-moving engagements, the improved acceleration and maneuverability of the modified Shermans proved decisive. By September 1944, as Allied forces approached the German border, nearly 90% of Sherman tanks in the European theatre had been upgraded with Moretti's transmission. The modification had become so standard that new tank crews were trained exclusively on the improved model, with the original transmission becoming merely a historical footnote. The culmination of Moretti's contribution came during the Battle of the Bulge in December 1944, when German forces launched their last major offensive in the West. The 4th Armored Division, rushing to relieve the surrounded garrison at Bastogne, covered over 100 miles in winter conditions in just 3 days, a remarkable feat that helped break the German offensive. In March 1945, Frank Moretti was awarded the Medal for Merit, the highest civilian award during wartime, in a private ceremony at the Pentagon. The citation stated, "Through exceptional engineering innovation, Mr. Moretti significantly enhanced the combat effectiveness of American armored forces, contributing materially to the Allied victory in Europe." Moretti's innovation received little public attention during the war due to security classifications. But among tank crews who fought across France and into Germany, the impact was never forgotten. As one veteran of the 2nd Armored Division put it decades later, "We didn't know who had fixed our tanks or how they did it. We just knew that suddenly we could outrun the Germans instead of them outrunning us. In a war where speed often meant survival, that made all the difference in the world."